Molecular shape and molecular polarity. The relationship between molecular shape and molecular polarity. The electronegativity between two atoms is the principal factor in determining the type of chemical bonding between the elements. If the electronegativity change is between 0.5 and 1.7, then the bond between the elements is polar covalent. For example, HCl. H has an electronegativity value of 2.20. Cl has an electronegativity of 3.18. The difference is 0.98, which makes this a bond that is polar covalent, as it's between the range 0.5 and 1.7. Since Cl is a stronger force of attraction on the shared pair of electrons, the Cl end of the bond develops a partial negative charge, and the H end of the bond develops a partial positive charge. This polarity in a bond is called a bond dipole. The vector used to represent a bond dipole points towards the more electronegative element. So here we have the H, which is slightly positive, Cl slightly negative, and we have HCl with the arrow showing the polarity of the more electronegative element. Here is another example. Try BeF2. Beryllium has an electronegativity of 1.57. Fluorine has an electronegativity of 3.98. Each BeF bond is polar. Fluorine has a greater electronegativity than beryllium. Due to the linear shape, the two polarities of the two bonds are directly opposite each other. This makes BeF2 a nonpolar molecule. Here is another example, CCl4 and CCl3H. Since the polarity of CCl is different from that of the CH bond, and the polarities of the molecules are different. The CCl molecule is symmetric around any axis joining the two atoms of the CCl bond. The polarities of the CCl bonds counteract each other, so the carbon tetrachloride molecule is nonpolar. However, in the case of CCl3H, the polarity of the HCl bond is different from that of the three CCl bonds. Thus, this molecule is polar, as shown in my diagram. Here are some other examples of the molecular shape, its bond polarity, and its molecular polarity. This will help you as you continue your work on this topic.